Hey there, geometry students. I'm going to go over problems 8 and 9 in section 10.2. This is page 691. And these are some of, honestly, the more challenging problems in all of geometry. And it's finding the area of regular polygons. So number 8, it says find the area of a regular triangle with an apothem of 2 feet. And again, just so you remember, the apothem is the distance from the center of the polygon to the side. The radius is from the center to the vertice. So anyway, what I know is this is 2. And just a reminder, the formula that we're focusing on is area equals 1/2 A, the apothem, times the perimeter P. And again, perimeter is the number of sides times the length of each side. Well, I know it's a triangle, so it's 3 sides. Oh, I need to figure out the length of each side, and that's the real problem. These problems are a process, all right? They involve figuring out the central angle. So I'm going to draw the 3 triangles here. And I've got 1, 2, 3. So my central angle equals 360 divided by the number of sides, so that's 360 divided by 3. So my central angle is equal to 120 degrees. So basically, each one of these central angles is 120 degrees. Like this is 120, that's 120. And of course, the one that I'm splitting in half is also 120. So a key little bit here is, I know that the apothem, the height from the center to the side, is perpendicular to that side. It's at a 90-degree angle. And that will actually split that 120-degree angle into 2 equal parts. Aha! I'm going to change colors. I just said it. If the whole thing is 120, then this portion of it has got to be 60. And that's where, let me go back. Boom. All right, so each one of these is 60 degrees. Okay. Now, wait a minute. It's a 30, 60, 90 right triangle. So what you end up doing really is dividing that by 2 and you get 60 degrees. The next process is basically I'm going to take this triangle, looks like this. And my cheater shortcut method is I remember my rules about 30, 60, 90 triangles. And the rule is 30, 60, 90, S square roots of 3, 2S. I know this one is 2 feet. This is going to be 2 square roots of 3 feet, and that's going to be 4 feet. So now, this is 2 square roots of 3. That is congruent to that. That's 1/2 of the puzzle. The other half of the puzzle means this is also 2 square roots of 3. So what does that mean? It means this entire side length is 4 square roots of 3. This is 4 square roots of 3. This is 4 square roots of 3. And now I can actually use my formula. I can plug this number, it has a radical in it, but it's still a valid side length, into my perimeter. So here we go. Let's break it down. So this is 3 sides times 4 square roots of 3. And that's my perimeter. And I need my calculator, right? And I'm just going to do it straight up on my calculator. 3 times 4 square roots of 3. And that works out to be 20.78. All right, so the perimeter is 20.78 times the apothem, which is 2, times 1/2. Half of 2 is 1. And that's exactly where that answer comes from. So what we did here, we do red, area equals 1/2 the apothem, which is 2, and then times 3 times 4 square roots of 3, and that is 20.78 feet squared. Sweet. That problem only took 5.5 minutes to do, and I've been teaching this for years. So, I mean, these are really challenging problems. Try number 9, or if you were doing problems 16 and 17, try those. I'm going to do example 9 now. And on example 9, or problem number 9, it says it's a regular dodecagon. That means it has 12 sides with a side length of 5. Okay, again, area equals 1/2 AP. And then I know things like n is equal to 12. I need to figure out A. That's a big problem. But I know the perimeter right off the bat. The perimeter is 5 times 12, or 60. So perimeter equals 12 times 5, which is 60. So now I have 60. A 1/2 equals capital A, of course, is area. All right. Whew. Here we go. Step number 1. Again, I'm going to have a bunch of these triangles. And I know each side is 5, right? So now, step 1, central angle, 360 divided by n. That's 360 divided by 12. 360 divided by 12 is 30. That's step 1. Now really, let me just focus on one of those triangles for a minute. And what I need to do is split it in half. So I have to take 30 and divide it by 2. So step 2, take the central angle and divide it by 2. So that's 30 divided by 2, and that's 15 degrees. So let's just break this down. So I've got this one right here. And I know that part's 30. And this little part right there is 15. Awesome. So what I'm going to do is I'm going to send that triangle down to try to blow it up for you. And when I do half of it, I get this. So I know this is 5, and half of 5 is 2.5. And if you're having a hard time, seeing where I'm getting these numbers from, each side basically has a triangle that goes into it, and I'm splitting each one of those triangles in half. And the reason I'm doing that is that vertical, the height, right, is perpendicular. So I end up with a 90-degree angle in each one of these triangles, and in this case, it's right here. So at this point, this is not a 30, 60, 90. It's not a 45, 45, 90. And also, what do I need? I need A. I need the apothem, the height of the side. I need this part right here. I need A. Well, you need to know how to use trig in order to solve this problem. And what it means is I'm standing right here at the 15-degree angle. I know the side opposite me, which is 2.5. I'm looking for the apothem, which is also the adjacent side. I think to myself, SOHCAHTOA, SOHCAHTOA. Yeah, you know what it is. Step 3, the tangent of 15 equals 2.5 over A. I'm going to solve it. A, these two end up switching places when you cross multiply. A equals 2.5 divided by the tangent of 15. So I do that on my calculator, 2.5 divided by tan 15. I get some crazy number, 9.33. I'm not going to do anything with it. I'm just going to plug that straight into my formula. So this is 9.33. I'm going to plug it in right there. So I get 1/2 9.33 times 60. So in my calculator, I know how to do half of 60. Half of 60 is 30. So I'm just going to take this 9.33 and times it by 30, and I get 279.9, and of course that is the answer in the book. And I think this, what are we units are in? We're in meters squared. Remember, area, 2 dimensions, you better have a squared unit. I kept it under 11 minutes. Let me know if that helps. If you like this video, please like it.